Hello everyone, this is my long presentation for the final project for cloud computing and the Internet of Things class at Harvard. The topic is Amazon Elasticache. Amazon Elasticache is an in-memory data store or cache for the cloud. Why do we need a cache? The success of a website is significantly impacted by the speed at which it can serve content to its user. To gain competitive advantage, it's very critical that frequently accessed content is served much faster. So for this project, I'm using Amazon Elasticache as the caching solution. Amazon Elasticache is a in-memory cache that's high performance, scalable, distributed in the cloud. The underlying technology is either Memcached or Redis. You can implement Amazon Elasticache with either one of these technologies. For this project demo, I'm using Amazon Elasticache as the caching layer and Amazon RDS MySQL database as my primary data store. And there is an AWS Lambda function that's created that is going to access the cache to retrieve the content. If it's not in the cache, then it's going to look in the primary data store, which is the MySQL database, and then retrieve the content from there. And so here's the list of tools and the versions that I'm using. So you got the Amazon Elasticache. I'm using the Memcached version 1.2.14, and then the Amazon RDS MySQL database version 5.6.27, and then I'm using AWS Lambda running on Python 2.7, and the AWS SDK for Python, the Boto 3 library, is also used. So the data set that's used for this project is obtained from this website. It's not a big data set. It's very small. It's nothing but a list of products of classic cars that I'm going to be uploading in a product table. So that is the content that will be served when the AWS Lambda function is invoked. So let's go to the demo. I'll walk you through how each of these tools are set up and how to run this code. So first thing that we will look at is how to set up the Amazon RDS instance. So this is very similar to what we did in homework 7. So we can go to the RDS dashboard. So before we do that, we have to create a virtual private cloud. So I go to the virtual private cloud, and you go to the dashboard and you start the virtual private cloud, and this is the option that we selected. So it creates a virtual private cloud with public and private subnets. Since I already created this, I'm going back to my list of VPCs, and you can see that there is a VPC called MyRDS VPC that's created. So when this VPC is created, it automatically created two subnets, a private subnet and a public subnet. And the corresponding route tables are created as well, and also the internet gateways. So now that the VPC is created, the next step is to create the RDS instance. So you can go to the RDS dashboard and then launch this visit, and then go to MySQL and select the MySQL option and go through this wizard to create the RDS instance. So this is also created. So I have a running instance called my RDS instance, and it's running in the VPC that I created earlier, which is called my RDS VPC. It has a private and a public subnet, and then it's associated with this security group called my RDS group. So if you look at that security group, the my RDS group, so I have an inbound rule that allows port 3306 to be run. We'll come back to this other one. So I have this RDS instance running, and the default database is called project DB, and this is the endpoint for connecting to this RDS instance. So with this RDS instance and this database up and running, so what I did was I connected using my MySQL client and connected to this instance and uploaded the list of products that I got from that website. As you can see, when I query this table, the product table, it gives me all the list of products, the product name, the product line, and all the other attributes associated with it. So this is, for this project, this is the content that we wanted to serve. Okay, so that's basically the setup of RDS instance, creating the database, uploading data into the tables. The next thing that we will look at is how to set up the Amazon Elasticache cluster. So if you go to the Amazon Elasticache cluster, you can go to the dashboard and start creating a cluster. So you have two options. One, the first one is the Redis, and the other one is the Memcached. Memcache is widely used, but Redis is the most recent one. But for this demo, we will be using Memcached. So you select Memcache, and we can fill out those details. And since I already created it, I'm going to pull up the instance that I currently have. So I've created a Memcache cluster called Memcache cluster, and it's created on a t2.small micro instance, small instance, and then this is the endpoint to connect to that Memcached cluster, and this is the port. So in the VPC, I have opened up that port for connection as well. Okay, so the next step is to create a Lambda function. So to create a Lambda function, basically we have to write the Python code. So here's the Python code. So what this script does is it basically added all the necessary libraries. It created some logging info, and it's connecting to the Elasticache cluster that I created. So as you can see, the endpoint here is the same as the endpoint on this Memcached cluster. So this creates a connection to the Memcached cluster, and then I'm connecting to the RDS instance. So you can see that the endpoint here is my RDS instance, and it's connecting to project DB, which is the same as what I have here, my RDS instance, and connecting to project DB. So both the connection to the RDS and the Memcached cluster are completed, this is the handler function. So every Lambda function has a handler function, So when the lambda function is invoked, it is basically calling this instance. So what I'm doing is I'm choosing a product that's in the database, which is S104698. So S104698 is Harley Davidson. So I'm preparing the select statement, and I'm logging the time before I make the query, and then I'm trying to retrieve this product from the Elasticache, from the memcache D cluster. So if it is found in the cache, it is going to print the content that's retrieved from the cache. If not, it's going to query the database, and then it's going to add this record to the cluster, to the Elasticache cluster, and then it's going to log the time after it ended. So we can know the time difference between before it queried the cache or the database and after it queried the cache or the database, and that time is reported as the elapsed time. So once we have this Python code created, we have to create a deployment package. So a deployment package is created by creating a directory of all the libraries that is needed for this Python code, and then here's the app.py, which is my Python script. So once you have all of this, you have to zip all this into a file. You can name the file anything you want, and once it's zipped, I'm basically uploading this to my S3 bucket, this one. Okay, so now the deployment package is created. The next thing to do is to create an execution role for the Lambda function. So you can go to the IAM, Identity and Access Management console, and I've already created this role. So you can look at the roles, and I have a role called the Lambda VPC execution role. So if you look at that, the policy that we need to add is AWS Lambda VPC access execution role. So this role allows me to call the Lambda function from within my virtual private cloud. And then the next thing to do is to create the Lambda function itself. So the way I did that is from the command line using the AWS CLI. So here's the command. So it's going to create a Lambda function called memcached lambda test in region US West 2, and it's going to use the deployment package I specified here, which is the project-app.zip, which is the deployment package. And then the role is the IAM role that we created here, the VPC execution role. And then it's going to run on Python 2.7, and I'm passing the subnets that are in this VPC, and I'm setting a memory size of 1 GB. So once I ran it, the Lambda function is created. So the Lambda function, since I already created it, it's already here. And this is the function that I created. So if you go in that function, you can see that it's the same code, the Python code that I just showed you. Okay, so now we've got the Amazon RDS MySQL database setup, and then we've got the Amazon Elasticache memcached cluster setup, and then we have created the Lambda function by creating a deployment package and giving its by giving a write execution role, and also creating the Lambda function itself. Now we can test this code. So to test it, basically I'm going to invoke this Lambda function from the command line. So I'm saying AWS Lambda invoke and the function name and the name of my Lambda function and the output to this text file. So I'm running the Lambda function now. So the Lambda function succeeded with status code 200, which means it's successful. So now if I go and look at the CloudWatch and look at the log file for this Lambda function, I can see that a new log is created here. And if I go inside that log, I'm sorry, that's not the latest one. Sorry, that is the latest one. So you can see that the connection to the RDS instance is successful and the data is retrieved from the cache. So in this particular case, the data is already in the cache. But if we go and look at a previous example, so you can see that S104698 was retrieved from the database and it took 3000 microseconds or 3 milliseconds. So when during this run, the data was not in the cache, so it was retrieved from the database, but the Lambda function also inserts this record into the cache. So the next time when I invoke that same function with that same product code, now you can see that it's retrieved from the cache and it took only 1000 microsecond or 1 millisecond. So that shows that by loading the content into the cache, you get a quicker response. And so this project demo is a simple example of showing how the cache delivers the content faster. But the same logic can be applied to anything that's served over the internet. So that's basically the Lambda function, the Elasticache cluster, and then the RDS. So to summarize, Amazon Elasticache, it's an important tool to consider if speed of serving content is vital. With Elasticache, you can quickly deploy an in-memory cache that's high-performance, scalable, distributed in the cloud. It's not a mandatory tool, but if you're hosting an application where latency is non-negotiable, then Amazon Elasticache is a good tool to pursue.